Okay, here is the review packet. I'm just going to do one problem at a time. So here's problem number 1, which most people did in class, but in case you didn't know what the heck was going on, let's go ahead and talk about it. So here I have the graph of the function f of x equals 2x squared, so that's got to be the parabola. The line t is tangent to the graph at x equals 1. So because it's tangent, that means the slope of the line, the slope right here, is going to be the same as the instantaneous rate of change on the parabola. So how do we get the instantaneous rate of change? We take the derivative. So the derivative of f of x is equal to 2 times 2 is 4, 4x. Okay, so we take the derivative. So that gives us the derivative function. But if I want to know what the slope is right here, I have to substitute in for x, the x value at that point. So the slope at that point is, I'm going to do f prime of 1, because x is 1, and I get 4 times 1, which gives me 4. Okay, so I know the slope right here on the parabola is 4, therefore the slope of the line is 4. So now if I'm trying to write the equation of the line, I have y equals mx plus b. I just found the m, it's 4. But now I need to find b. I can't tell by looking at the graph. I know it's going to be a negative number, but I don't know what. So instead, what I need to do is I need to find a value for x and y, and then I'll be able to solve for b. Well, I'm halfway there. I have a point, and I know the x-coordinate is 1. Now I need to find the y-coordinate. Well, the y-coordinate I can use the parabola equation for, because this point is on both the parabola and the line. So I'm going to substitute in to the f of x. I'm going to put in my 1. F of 1 is equal to 2 times 1 squared to get the y value. So f of 1 is equal to 1 squared is 1, 1 times 2 is 2. So that is 1 comma 2. Now I can substitute that in for my x and y down here, 1 comma 2. So I get 2 is equal to 4 times 1 plus b minus the, well, that's 4 times 1, which is 4, plus b, minus the 4 from both sides. I get b is equal to negative 2. Therefore, y is equal to 4x minus 2. So I've just shown through all this work that that is, in fact, the equation. All right, find the x-intercept. Well, now that I have the equation, I can find its x-intercept by changing y to 0. When I have an x-intercept, y is equal to 0. So I'm going to have 0 is equal to 5x minus 2. Add 2 to both sides. Divide both sides by 4. And I get x is equal to 1/2. So the x-intercept would be 1/2, comma 0. Another way of writing it. Okay, either way is fine. All right, the shaded region R is enclosed by the graph of f and the line t and the x-axis. So I want this shaded area, goes all the way down there, all the way up here. So to find the area under the curve, I need to integrate. So I need to integrate the curve, which is 2x squared, and I need to do it from, they say, what is this, enclosed by the graph of line t in the x-axis. Well, this curve I know goes to 0, 0. So that's where the x-intercept is, right here. And I know it intersects with the line over here at 1. Okay, so I could verify this. I could figure out what the x-intercept is of my f of x. So I could, I could do that extra little bit of work. I want f of x to equal 0, so I find out what that coordinate is. So 0 is equal to 2x squared, divide by 2. 0 equals x squared, square root 0, and I get x equals 0. Okay, so I know I'm going from 0 to where it intersects with the line, which is at 1, okay, the x-coordinate. So it's going from 0 to 1. And when I do integration, I have to write the directions. So integrate the function 2x squared in regards to the variable x. All right, so that, though, would get me all of this area. And that's a problem. I only want the shaded part. So I need to get rid of this triangle here. So I need to get rid of this triangle. So there's a couple ways I could do that. I could use integration and integrate underneath the line, but I since I recognize the shape, I think I'm just going to figure out what is the area of that triangle. So I'm going to subtract the area of this triangle. I found this coordinate. This is 1/2. So from 1/2 to 1, I know that my base is equal to 1/2. And then the height, I know it's 2 units up, so my height is 2. So the area of my triangle is 1/2 base times height. So I can just do that. I can just do minus the area of the triangle. So that is an expression for the area of R. I also could have integrated underneath this line. So I know some people wrote it like this. So you could write it like that, or you could say, okay, I want 2x squared dx from 0 to 1, but then I want to subtract off this area underneath this line. This line is 4x minus 2. Oh, sorry, that's kind of in the way, dx. And it would be from 1/2 to 1. So I could also set it up that way. But I think that is too much work, okay, because next we need to find the area. I think it's easier to find the area of a triangle by just doing 1/2 base times height. So that's what I'm going to do. I'm going to use the 1/2 base times height. All right, so if I integrate this now, I need the antiderivative of 2x squared. So the antiderivative, I keep my 2, I add 1 to my exponent, and then multiply by 1 over that exponent. So I have 2 times 1/3 x cubed, and that is going to be from 0 to 1. And after I get that, I'm going to subtract this. So if I multiply this together, 1 times 1 times 2 is 2 over 4. Okay, this is the area of my triangle, which is equal to 1/2, but I'll worry about that in a second. Okay, so now I'm going to evaluate this. I'm going to plug in my 1 first. So I have 2 times 1/3 times 1 cubed minus 2 times 1/3 times 0 cubed, and I still have my minus 1/2. That's from here. All right, 1 cubed is 1, 1 times 1/3 is 1/3, times 2, that's 2/3. 2/3 minus 0 cubed is 0, 0 times 1/3 is 0, 0 times 2 is 0, and minus 1/2. So I have 2/3 minus 1/2. I'm going to have to change that to a common denominator. I'm going to change it to a 6. So I have 4/6 minus 3/6, which gives me a final answer of 1/6. And since we're asking for an area, it's going to be units squared. And that is problem 1.